Hello, my dear friends, and now we are going to learn about the inductors. So, first question first, what are the inductors? Well, just take any copper coil and twist it like this. So, this will going to become inductor. This is the simplest inductor we can have. So, just twist yourself up. Well, what happened with just the simple twisting? You might asking. Well, let me tell you that if this voltage is VA and this voltage is VB, well, so what I mean with that, let's see. If this is 10 volt and somehow I have arranged this, don't count technical things, so I can either have 20 volts, you want more, maybe 100 volt, you want even more, 1000 volt. Well, where these magical numbers are coming from? The energy is increasing or the voltage is increasing, but how it's happening? Well, this phenomena is known as induction effect. So because of the induction, current don't change. Well, remember 2 points that I would like to mention and highlight here. So let's learn that. No change of current. No change of current. Well, this is the first point we have, and the second point is voltage can vary. Voltage can vary. In our case, it has increased many times. Like if we compare this one, this is multiplied 10. You can do even more. In this case, we are having multiply 100 itself. So we can do this. How? But how? That is the question. Well, that is a valid question. So let me clarify on this one. Well, this is the inductor. Imagine that this is the inductor itself. Now, let's see what is happening here. So the current is moving along and the electron goes in the opposite direction. We know that. So I am making it up so that we can see that what actually is going to happen in this case. So let's see something like this. It's gonna on and on and on. So this is the flow of the current. So when the current is flowing, we know there surely be a voltage. Well, obviously there is voltage. So there is voltage in the first ring. Now the interesting thing starts happening in the presence of magnetic effect that is produced itself by the current. Yes, current produces the magnetic effect as we have discussed in the galvanometer section. Now this is gonna affect and produces a thing that is called as flux, magnetic flux that travels through the space. It do not require any medium to travel, so it do not require a medium, so it gives the part of v1, a little part of the v1, let's say it is v naught, and additionally the current that is coming is carrying the voltage itself, so it is increasing. Well, in terms of number, let me show you that if it is 10 volt, it gives extra 1 volt here, and when the current reached, it gives 10 volt, so we have 11 volt here. So where this extra 1 volt is coming? Because of the effect, that is flux, magnetic flux. Magnetic flux is giving or responding to one thing. Well, this is one of the best experiment I ever read, done by the Faraday. Well, let me show you that what was the experiment itself. Let's make the coil first. So this is the first coil we have, and let's connect it with the magnet. And now another one. Actually it's coiled up, so I'm trying to show the coilings here. And now there is another thing in which we place the galvanometer to check that if the current is coming or not. Well, what actually happened when you switch it on and the current starts flowing in this direction, it is definitely having voltage because of this battery, so it is having its energy source. But what magically happens is, because of the induction effect, the magnetic effect that we saw, the flux part, this also gets charged. So our second coil also gets the current and voltage. So galvanometer starts responding. So we know that something is coming from the coil 1 to coil 2 without even having physical contact. Well, this is the fundamental basis of making the wireless charging systems that we are trying to develop these days. We have developed the initial versions of it already, but we are trying to develop it in the next level. Well, this became the fundamental concept of and for the transmitter and receiver that we have. Like, you are calling someone, you are calling your friend living somewhere around mobile 1, mobile 2, or cell phone 1, cell phone 2, whichever way you like to call it. So you are calling to your phone act as transmitter. Surely there are other things in between, but we are ignoring that for the sake of simplicity. And ultimately this is the receiver. So your phone, your friend and you can communicate both the ways. So one is transmitter, one is receiver. Actually, in our cell phone, both the systems are there. Otherwise, we are just either transmitting or receiving. Like in the radio stations or in the television stations, they only transmit and we receive. Everyone is a receiver. Everyone's TV is having a receiver. Like you are having an internet receiver, but on the calling part we want to respond also, so we use dual channel for that. We are going to discuss that in detail when we will study about the AC section. That will going to be our second last section, that is digital analog communication part. So this is the fundamental basis, and the discovered name was Faraday, and he gave a law to us. Well, what was the law? That EMF. Well, assume that EMF is the voltage itself. So EMS is directly proportional to d of phi divided by dt. Well, I'm writing in a differentiated form, but you can simply imagine it as the rate of flow of flux. I'm also writing that so that you can see that clearly. EMF is rate of flow of magnetic flux. So this will gonna help us to understand the thing. EMF is the rate of flow of magnetic flux. So magnetic flux is providing us the rate of the flow. Okay, so we got that. So actually EMF now can be written as N d phi by dt. Well, that is all about it. But there is a serious flaw in this. Well, n is number of turns, by the way, number of turns. Like in our case, in the previous one, we were having 1 turn, 2 turn, 3 turn, 4 turn, and 5 turns. So this way, how many turns you would like, you can add that up. Okay, so this is about the Faraday law, but there is a serious flaw, as I told you. So Lenz corrected this equation again and gave us another law, another important law, or you can say it as a correction law, I would like to call it. So that is EMF. This is EMF that is actually proportional to d phi by dt. Well, what is the difference? This negative sign is all the difference. That's it. Well, this negative sign is that important, Om? Well, obviously that negative sign make everything out of it. So what does it actually mean? It means that the flux that is produced in coil 2 itself opposes the place that opposes the EMF. Well, I hope you have not got it. Okay, let me show you that. Well, in this case, as I showed here in the figure, that the current is going upside, as you have noticed. But in this coil, I have shown that the current is going on the opposite side. So that's what it means. It is opposing the flow that is producing it. Well, I will add the definition in the note section if you want, but that's the whole concept of it. Okay, now with all that said, there must be the series parallel connection as in all the devices we can have. So in inductor, when we have the connection, in series, let's say, okay, I missed one thing. So let's study that one first. Actually, we have the space here. Okay, so flux can also be written as Li. What is L? Well, L is inductor, inductor itself. And also EMF can be written as EMF can be written as is equals to, in place of phi itself everything is happening, so the equation remains the pretty much same. Let me write it completely so that it will not going to confuse you. And wherever I am not even writing the B, you have to understand that it can only be magnetic flux, and for the magnetic we write small b, so that we learn that the flux is magnetic in nature. Okay, now this is gonna be equal to, actually phi is gonna be equal to Li. So what we're gonna do is separate this thing. So minus L, or let's just say remove N, as this is number of turns. We don't want number of turns right now. So L di or di capital by dt. So in short and simple, EMF can also be written in this way, where L is the constant and I is surely be the current. So this is one more way to write that up, and this L is actually going to give us everything. And before this line, if you try to follow, yes, that's the proportionality thing, you are right, phi is directly proportional to I. Yes, exactly. Now the next part, here we have that. Now when we add the batteries, and let's say this time L1 and L2. So first question first, what are its formulas? Well, in series and parallel, let's place it first. Okay, my drawing messed up a little bit. Now it seems a little bit good. So what we gonna have, so let's place the numbers first. 10 volt battery, 10 volt battery, well, you can take any volt battery, doesn't matter. L1, L2, I instead of numbers I just wrote that, but you can take the numbers, it will not make any difference. Okay, so now what is the series parallel formula in this one? Well, for series, which is the first case, as we can see here, is L1 plus L2. Well, same as the resistance series. And in the parallel case, we simply have the inverse part. So 1 by L1 plus 1 by L2, same as the resistance. So that's it. Yes, that's it. That's all the thing that we need to learn. Okay, so this is all about the thing in the series and parallel that we can derive, but we are not going to into derivation part, at least for now. We are just learning it for the sake of the logical purpose. Well, you can find its derivation quite easily. I will try to add that in notes too, so that you can see if we can write that and how to do that. Okay, one more important thing, is there any energy? Yes, there is surely with energy, and this time the energy is half Li square. Well, similar to E is equal to half CV square. Yes, in place of V, we are having I, which is current, and L, which is inductor. Well, the unit of inductor itself, let me write the unit of inductor. We have studied everything except the unit itself. It is made in the name of Henry. So we write H, capital H. So the unit for the L or inductor is actually Henry. So energy that we found is half times inductor times current square. Well, I wrote the same thing again, but now you got the fullest of understanding. So you have learned the basic part of the inductors. So congratulations, my dear friend, you have studied the resistance, capacitor and inductor. Now you are even able to recognize and understand all the concepts behind the scenes, because these three are present everywhere, no matter how many old or new electronic devices you are playing with or just messing around. You are gonna find that everywhere, everywhere, literally everywhere. So this is everywhere. Okay, now we are on our final topic, which is LCR circuit. What if these three or maybe two comes together in the final section? So we are going to cover that in the next one. Till that, take care, God bless, and Namaste.